So we are given a rectangle here in which we have to find x and y. So by looking at the rectangle, we already know that these angles are going to be 90 degrees. And now because we need to find x and y, there are two variables here. Therefore we know that there'll have to be a simultaneous equation. So with a rectangle, the corresponding sides are going to be equal. That means this side is going to be equal to this side and this side is going to be equal to this side. So if I put lines here, I'll be able to show that the sides are equal. So since I've put one line here and one line here, I show that these two sides are equal. I'll put two lines here, similarly over here, two lines to show that these two sides are equal. Therefore, to find x and y, I'm able to create a simultaneous equation. Now because the sides are equal, I will know that 2x minus 3y is equal to 11 and 3x minus 2y is equal to 4. So I'll be able to create a simultaneous equation. So 2x minus 3y is equal to 11 and 3x minus 2y is equal to 4. So I'm planning to use the elimination method to solve this question because in my opinion it saves time. And for the elimination method to work, you need the coefficients of the variable which you're eliminating to be the same. So multiplying equation 1 by 3 and multiplying equation 2 by 2 will give me the coefficient of x as 6, therefore allowing me to eliminate it. So if I multiply equation 1 by 3, I will get 6x minus 9y is equal to 33. And for equation 2, by multiplying it by 2, I'll get 6x minus 4y is equal to 8. Remember, you're multiplying each and every term, so every term must be accounted for to give you these. So this becomes my equation 1 prime and equation 2 prime. Again, these are very similar to the Roman 1 and Roman 2 which we said in our earlier videos. It's just there for a distinction. So I'll be using these two equations to get the values of x and y. So because I'm using x as my variable to eliminate, I'll have to either add them or subtract them. If I add them, I'm going to get 12x, but if I subtract them, I'll be getting 0x, therefore eliminating x. So now because I want to eliminate my variable of x, I'll be subtracting the two equations. So 6x minus 6x gives me 0x, minus 9y minus 4y. So because there's a two minuses, it becomes plus, so it's minus 9y plus 4y. That gives me minus 5y. And 33 minus 8 is going to be 25. So because of this, I'm able to know my values for y. I've eliminated x, therefore leaving me with only one variable, which is y, and I can get my answer for y. So minus 5y is equal to 25. Therefore if I divide both sides by negative 5, I get my y as minus 5. So that's my y done. Now if I go on to x, I will use y as negative 5 and substitute it into any one of these equations, literally any one of these four, to get my value for x. So I'll substitute this into equation 1 here, seems to be the easiest. So substituting them into equation 1 will give me 2x minus 3y, but my y is negative 5, so I substitute it, is equal to 11. And now I'm able to show that 2x plus 15 is equal to 11, because minus 5 times minus 3 is equal to plus 15, and it's going to be a positive number. So if I move the 15 to the other side, I will get 2x is equal to minus 4, and if I divide both sides by 2, I get my x as minus 2. Therefore for this question, we've got our values for the variables x and y as x as minus 2 and y as minus 5. So now that we've got our variables as x as minus 2 and y as minus 5, substituting them into these will give you the same answer. So if I substitute x as minus 2 and y as minus 5 into this equation, I will get my answer is 11. And substituting x as minus 2 and y as minus 5 into this equation will also give my answer as 4. Therefore all the corresponding sides are equal, thus making the answer correct.